Okay, let's look at the review problems from Chapter 9. And the first one we're going to look at is number 5, which says that in 2007, M&M sales were $238.4 million, which was 13.2% of the total chocolate candy sales. What was the total amount spent on chocolate candy in 2007? So for this one, what we'd want to do is we'd want to write a percent statement. So a percent statement would be something like this. M&Ms are some percent of total chocolate sales. Okay, so there is our percent statement. Then we've got two ways we can solve that. We can either turn that into an equation, or we can turn it into a proportion. Let's just do both just to remember. And so if we're doing it as a percentage, or as a equation, what we're going to do is we're going to first put in what we know. Let's see, the M&M sales we know are $238.4 million, and that is 13.4% of the total, which is what we don't know. So if we're writing this out using the equation, remember we take everything we know, bring it down. 238.4 R, keyword for R is the same as is going to become an equals. Some percent, we're going to turn that into a decimal. Remember, anytime we're dealing with the equation, we have to turn it into a decimal. Of becomes multiply. The total chocolate sales is what we don't know. And now we can solve that for x. So I'll divide both sides by 0.134. And that will give me 238.4 divided by 0.134 gives me 100. Let's see here, 238.4. Oh, that's 2. Sorry, misread that. Okay, so that is a point. There we go. So we get x is about 1806. Or, remember this was in millions, so $1,806 million in total sales of chocolate. If we were doing it as a proportion, then we would have let's see, what would we? So we would have our percentage, which is 13.2 over 100, equals is over of. So it's a percent of. We don't know what that is. All right, and what's on the other side of the is going to be the 238.4. All right, so this is over of is kind of the way most people remember it. And then you would set up your cross products. So 13.2x equals 23840, and then divide both sides by 13.2, and you'll get the exact same answer. Remember, with the proportion, you don't have to change out of the percentage, whereas with the equation, you do. So that's number 5. The next one we're going to look at is number 9. Number 9 says Jacob wants to defer his income taxes of $11,400 for 6 months. If he must pay an 18% penalty compounded monthly to do this, what will his tax bill be? So for this one, we could use the formula A equals P times 1 plus R over M to the NT. And if we do that, we have to figure out what we know. So in this case, we know that what he's starting with, that he's deferring, is the $11,400. We know that it is 18% penalty, so we're going to turn that into a decimal, 0.18, over its compounded monthly, so n would be 12, raised to the 12 times, and this is for 6 months. So the t would be 1/2. And then I'd plug that into the calculator. And again, just for practice, we can plug the whole thing in. 11,400, parenthesis, 1 plus 0.18 divided by 12. And remember, we don't have to worry about any extra parentheses in here because order of operations is already going to do that for us. Raised to the parenthesis 12 times 1/2. All right, it comes out to be $12,465.25. Now you could also do that on the calculator if you wanted to. All right, if we went and we did it using the finance app, what we would say is our number of payment times is going to be 6 because it's for 6 months. Our interest rate is 18%. Our present value is 11,400. We are not making any payments. It's the payments or the compounding is 12 per year, and we want to know what the future value is, so we hit alpha, solve, and it gives us the same number. Okay, either way is fine with me. If you're going to do it this way, please write this down so I can see what you did, and then if you made an error, I can give you some partial credit once I figure out what you did. All right, the next one is going to be number 10. Number 10 says, Palma wants to establish a fund for her granddaughter's college education. What lump sum must she deposit in an account that pays an annual interest rate of 6%, compounded monthly, if she wants to have $10,000 in 10 years? So, this is also using this formula, but in this case, we know how much we want at the end. We want $10,000 at the end, and we don't know how much we have to begin with. Our interest rate is 6%, so we turn that into a 0.06. Divided by, it's compounded monthly, so that's going to be 12, raised to the 12 times 10. And then if we do that using the calculator and not using the finance app, you would just plug in 10,000, and then instead of times, like we did up here, we would divide it by parentheses 1 plus 0.06 divided by 12, parentheses raised to the parentheses 12 times 10. Okay, and that tells us we need to have $5,496.33 to start with. Okay, now we could also do it using the finance app. If we go into finance, okay, for this one we're dealing with 12 months a year for 10 years, so it'd be 12 times 10. And you just put that in and it'll calculate for you. Our interest rate is 6%. Our present value we don't know. Our payments, we aren't making any payments. And our future value is going to pay out to us $10,000, so we put in a negative 10,000, and then it's monthly. So our present value is $5,496. Okay, next one, number 15. Number 15 says, calculate the finance charges for the following credit card account for August, which has 31 days, using the average daily balance method. July's balance was $275, and the annual interest rate is 18%. So remember, what we're going to do is we're going to, for this one, we're going to set up a table. And that table is going to be a lot like the one that's on page 418. And page 418, table 9.3, shows you what you want to do when you're, let me just throw this under here real fast, when you're solving these. You want to figure out how many days you've got at a particular balance, then take that number of days times the balance on those days, and that gives you a total balance from that segment of the month. And you do that for each of those. And then what you're going to do is you're going to take this, you're going to average all of those out as to how much you had every day. Okay, so you're going to get an average, which is going to be somewhere around in the 200s. Okay, and then you're going to use that average daily balance to find your interest. So let's go ahead and set this one up. So it says we're starting out July's balance is $275. So I'm going to set up my table here with days, balance, okay, and I'm starting with a balance of $275 at the end of July. And if you look at your chart here, it's going to stay that until we have something happening on August 6th. So basically August 1st, 2nd, 3rd, 4th, and 5th, we're going to have that $275 balance. So over here, we're going to get a total from this line, which is going to be 5 times 275. Then, on the 6th, we make a payment of $75. So now our balance goes down to 200. And from the 6th through the 11th, it's going to stay that. So 6, 7, 8, 9, 10, and 11, it's going to be at a $200 balance. So that's 1, 2, 3, 4, 5, 6 days at a $200 balance. Alrighty. Then on the 12th, we are charged $115 for close. So now we're going to go up to $315 as our balance. And it's going to be that for the 12th through the 18th. So 12, 13, 14, 16, 17, and 18, which is 1, 2, 3, 4, 5, 6, 7 days at $315. Okay. And then on the 19th, we charge $20 for gas, so we go up to $335. And so it's the 19th through the 23rd is that, 19, 20, 21, 22, 23, 1, 2, 3, 4, 5. 5 times 335. And then on the 24th, we charge $16 for lunch. So it's going to bring us up to $351. And so that's going to be the 24th, 25th, 26th, 27th, 28th, 29th, 30th, and 31st for August. So that's 1, 2, 3, 4, 5, 6, 7, 8 days at $351. So now what we need to do is we need to find our totals here, and then we can find what our average balance is. So I'm in the calculator. I'm going to take 5 times 275 plus 6 times 200 plus 7 times 315 plus 5 times 335 plus 8 times 351, and that gives me a total here of 92.63. Now what I need to do is divide that by the number of days, which is 31. All right, and that comes out to a average balance of about 298.81. All right, and now we're just going to find the interest. So interest, and it's going to be using simple interest. I equals PRT. So for our principal, what we're going to use is we're going to use our average daily balance, which is 298.81. Our interest rate, let's go see what it said was the interest rate, is 18%. So we'll turn that into a decimal, so 0.18. And then it's time, and our time is going to be just a part of a year. It's 31 days out of the 365 days in the year. Okay, so now on my calculator, times 0.18 times 31 divided by 365. And that gives me, when I round that off, gives me an interest for that month of $4.57. All right, and a good example to walk through with that is the example number 4 that starts on page 417. All right, so that's the average daily balance problem. All right, the next one we're going to look at is problem number 16. So for 16, it says Piers is saving for his retirement by putting $175 each month into an ordinary annuity. If the annuity pays an annual interest rate of 9.35%, how much will he save for his retirement in 10 years? Alrighty, so for this one, I'm just going to use the finance app on the calculator. You could go back and use that formula. The 9.4 video, I show how to do that, but for this one, I'm just going to show you how to do it on the finance app of the calculator. So we have N, we have I%, we have present value, we have payment, and we have future value, and then we have the other stuff that's in there. All right, so let's look through what each one of those is going to be. It says that he's putting $175 each month, so it's a monthly thing, for 10 years. So the number of times that he's doing this is going to be 12 times 10. The interest rate is 9.35%. The present value is we're starting with nothing in there. And what we're doing is we're putting money in, so since it's coming out of our pocket, it's a negative, and we're putting in $175 per month. All right, and the future value, that's what we want to know. And then the other three things that are on there are payments per year, compoundings per year, and PMT, which is when the payment occurs. Payments per year, since we're doing 12, these are going to mirror each other for our purposes in the class, and then for our purposes in the class, we're using end all the time. So put all those things in, 120 for N, 9.35. Don't have to have a 0 for present value, negative 175 for your payment, and then you don't care what's on future value. You make sure that these are right, and then on future value you hit solve, and it gives you that you're going to have your future value is going to be about 34,543.31. Okay, so that is your answer on that one. And again, that's just using the calculator app, finance app, instead of the formula. So that was number 16. Number 17 is the next one. So for number 17, it says find the monthly payment needed to have a sinking fund accumulate to $2,000 in 36 months if the annual interest is 6%. All right, so N, I%, present value, payment, future value. Those are the new ones we need. I'm also going to put payments per year and compoundings per year. All right, so for this one, we're doing it monthly again, and we're doing it for 36 months. So we can actually just plug in 36 right here. Or you could say 12 times 3. Your interest rate is 6%. Your present value is 0. Your payments, you don't know what those payments are going to be. And your future value is you want to bring that up to $2,000. And your payments and compoundings are going to be monthly. So you plug that into the calculator. And calculate your payment, and your payment should be negative 50.85 when you round it off. So It's a negative because it's paying you, or it's coming out of your pocket. Alrighty. So that is going to be your monthly payment in order to have $2,000 after 36 months. All right, number 19 is the next one. $19 says you are making monthly payments of $300 into an annuity that pays 9% annual interest. How long will it take to accumulate $10,000? So here's my pieces. So we are making monthly payments into an annuity, and we want to know how long it'll take to accumulate. So we do not know what it is. Our interest rate is 9%. Our present value is 0. And our payments are negative 300 because we're paying them out. And we want to get our future value up to $10,000. And we're doing this monthly. All right, so I'm going to plug all that in. And just hit alpha solve on the number of months, and that comes out to be about 30 months when we round it off. Okay, so you can find anything of these unknowns. You can find your payment, you can find your number of payments, you can find your future value, your present value, any of those things. All right, the last one from Chapter 9 is number 21. Number 21 says, find the monthly payment necessary to pay off a 4-year amortized loan of $5,000 if the interest rate is 10%. So interest rate is 10%, 4-year loan, and it's monthly, so that's going to be 48. Present value, we're currently borrowing $5,000. All right, payment and future value. Payment is what we want to know. Future value, when we're going to get that thing down to $0. And payments per year, compounding per year, that's going to be 12. Okay, just because all of these were monthly doesn't mean that they have to be monthly. All right, it's just the way it worked out on the examples that they had here. So 48, interest rate is 10%, present value is 5,000, payment we want to know, future value is 0, payment per year, compounding per year is 12, and then we'll go up to the payment. We'll hit alpha solve, and it says we need to pay $126.81 each month on that loan. So that is the Chapter 9 review problems.